Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 15.2, which is going to deal with angles and inscribed quadrilaterals. Now, for today's lesson, we have one learning goal, and our learning goal for today is that you will be able to use the Inscribed Quadrilateral Theorem to find the angle measures. So we're going to talk about inscribed quadrilaterals, which means you have a circle and there's a quadrilateral inside that circle. And we're going to talk about how to find the measure of the angles of the quadrilateral that's inscribed in a circle. So, before we get to our theorem today, let's kind of go through and talk about a little bit of a concept. So, this is our circle and then our inscribed quadrilateral. And for part A, it wanted us to go through and measure the four angles of the quadrilateral, which I have already gone through and done. So the measure of angle A is 95, the measure of angle B is 60, the measure of angle C is 85, and then the measure of angle D is 120. Now for part B, they want us to go through and find the sums of the indicated angles. So for the first one here, it's the measure of angle A plus the measure of angle B. Okay, they're saying DAB and ABC. The letter in the middle is really going to indicate which one we want to go to. So it's angle A and angle B. So angle A is 95 degrees and angle B is 60 degrees. If we go through and do 95 plus 60, we get 155 degrees. Now for the next one, we have the measure of angle A plus the measure of angle C. So the measure of angle A is 95 and the measure of angle C is 85. So if we do 95 plus 85, we get 180. So when I add 95 plus 85, we get 180. Now, if I kind of run through the rest of these, so the measure of angle A and the measure of angle D. So A is 95 degrees, D is 120. So if we do 95 plus 120, we get 215. So that's angle A and angle D. For this one, they want the measure of angle B and the measure of angle C. So B is 60, C is 85. If we do 60 plus 85, we end up with 145. Next, we take a look at the measure of angle B plus the measure of angle D. B is 60 degrees, D is 120. 60 plus 120 is going to give us 180. And then the last one is the measure of angle C plus the measure of angle D. So the measure of angle C is 85 and the measure of angle D is 120. So if we do 120 plus 85, we end up with 205 degrees for the sum of those two. Now, the reason we do this is it's going to lead into the inscribed quadrilateral theorem. And I'm going to point out what it is before we talk about it. And that is look at the two purple numbers that I wrote down. Okay, 180 degrees is for the measure of angle A plus the measure of angle C, and for the measure of angle B plus the measure of angle D. So all of these are all different except for these two add up to be 180. So what is special about these two? So we have angle A and angle C. Angle A and angle C are these two angles right here. And then if we look at this one, it's angle B and angle D. B and D, what do those two sets of angles have in common? B and D, and then A and C. A and C are opposite of each other, and B and D are also opposite of each other. So That kind of ties into our theorem, which states if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So this opposite angles are supplementary is our key in our lifeline today and going to allow us to do everything for our problems today. So when we talk about supplementary, that means that they add up to be 180 degrees. So that means if I know the measure of angle A is 95 degrees and I didn't know C was 85, okay, because these two are supplementary because they're opposite, all you have to do is do 180 minus 95, and that would tell you the measure of angle C. Same thing for D and B. If I know the measure of angle B is 60 degrees, to figure out the measure of angle D, you just have to do 180 minus 60, which gives us 120. So, opposite angles in an inscribed quadrilateral are supplementary, so that means they add up to be 180 degrees. Okay, that's your key today. Opposite angles add up to be 180 degrees. All right, so with that said, we are going to use that theorem to help us go through and solve our questions for examples 1 and 2. So with that said, let's go ahead and move on to example 1. That's going to ask us to use the Inscribed Quadrilateral Theorem to find the angle measures of the quadrilateral. So if we look at part A, so we have our circle and then our inscribed quadrilateral ABCD, and they tell us the measure of angle A is 74 degrees and the measure of angle D is 85. So we need to go through and figure out the measure of angle B and the measure of angle C. So the inscribed quadrilateral theorem states that opposite angles are supplementary, which means they add up to be 180 degrees. So if we start with trying to find the measure of angle B, what angle is opposite of angle B? Okay, the angle opposite is D, the 85 degrees. C is right next to B, as is A, so the only angle that's opposite is D, the 85 degrees. So what this means is that the measure of angle B plus the measure of angle D is going to equal 180 degrees. Okay, so that's the inscribed quadrilateral theorem, that these two add up to be 180. So we want to figure out the measure of angle B, and they tell us that the measure of angle D is 85. So this is the measure of angle B plus 85 degrees equals 180 degrees. So all you have to do, and I'm drawing this one out, I won't do this for every problem. All you have to do from here is just do 85 subtracted to 180. So it's going to be 180 minus 85, and that's going to tell us that the measure of angle B is 95 degrees. And that's our answer for the measure of angle B for part A. Now, there's one last part to look at, and that is the measure of angle C. So we're going to take a look at that here real quick. This one I'm not going to draw out as long. So for the measure of angle C, okay, we need to use the angle that is opposite of angle C. So the angle that's opposite of C is A, and that's 74 degrees. So to figure out the measure of angle C, it's just going to be 180 minus 74. So if we do 180 minus 74, because 74 is the angle that's opposite of the angle we're trying to find, that tells us the measure of angle C is 106 degrees. So when you are going through and doing these problems on the homework, know this: opposite angles are supplementary, which means they add up to be 180. So if you know the measure of the angle opposite, you can figure out the measure of your angle by just doing 180 minus that number. So just for matter of purpose and extra practice, if we take a look at part B, so we have our quadrilateral. They tell us the measure of this angle is 71, this one is 80, and they want us to figure out the value of x and y for this inscribed quadrilateral. So let's start with x. X is this angle right here. The angle opposite of x is going to be the 80 degrees. So all we have to do is 180 minus 80, and that is going to tell us that the measure of x is 100 degrees. And that's our answer. So for whatever angle you are trying to find the measure of, okay, start there, find the angle that's opposite. Those two have to add up to 180. So in this case, where we are just basically trying to figure out the quick measure, all you have to do is just do 180 minus that number. So if we wrap up then with figuring out the measure of y, well, the angle opposite of y is 71 degrees. So we're going to do 180 minus 71. If we do 180 minus 71, we find that y is going to equal 109 degrees. And that is our answer for part B. So that is how you go through and do example 1. For parts A and part B, you would do the same thing for C and D. Figure out what angle you're trying to find the measure of. Find the angle that's opposite. Those two are supplementary, so they add up to be 180. So all you have to do is just do 180 minus the angle you know, and that tells you the measure of the angle you're trying to figure out. So opposite angles are supplementary. Adding up to be 180 is going to help you go through and do example 1. So example 1 is just straight finding the measure of the angle. As we move into example 2, you're going to see that we have different expressions for angle measures instead of just straight measure of angle B, measure of angle C, or X or Y, Y or X. So it's going to up the game a little bit and include a little bit of algebra with our geometry. So that is it for example 1. Again, opposite angles are supplementary. All right, for example 2, we're going to carry this idea of the Inscribed Quadrilateral Theorem. We're going to use this to find angle measures of the quadrilateral, much like we did for for example A. Now the difference though with example 2, as you can see, there's no angle measure involved at all in this problem, yet it's a host of expressions. So how do you go through and do these types of problems? Well, the first thing you need to do is take a look at your diagram. So we have our circle here with the inscribed quadrilateral PQRS. One thing to note is that they tell us that the measure of angle P is 5y plus 3, Q is y squared plus 53, R is 15y plus 17, and they don't tell us anything about S. So, how do we go through and do this? Well, they give us 3 different angles. We need to choose the 2 that are opposite of each other. Okay, the 3 that we know are P, Q, and R. The 2 that are opposite of each other are angles P and R. So that means we want to use this 5y plus 3 and this 15y plus 17. Because those 2 are opposite of each other, that means that they're supplementary and they add up to be 180. So, if we know they add up to be 180, what we're going to do is take both of these expressions, add them together, and set equal to 180. So, we'll start with 5y plus 3. plus 15y plus 17 equals 180 degrees. So now that I have this set up, all it really is from here is just using your algebra skills, combining like terms, adding or subtracting, and then multiplying or dividing to figure out what y equals. Okay, the first thing you want to do is combine like terms. Okay, we have a 5y and a 15y. 5 plus 15 is going to tell us 20y. Then we have 3 and 17, so 3 plus 17 is also going to give us 20, and that equals 180. So now that we have it simplified, this should look a little more common for what you're used to. So 20y plus 20 equals 180. All we have to do here is subtract the 20 and then divide 20 to whatever that value is. So if we subtract 20, we end up with 20y equals 160. And if we divide by 20, we find y to equal 8. So now that I know y equals 8, all you have to do from here is just plug 8 in for y, for 5y plus 3, for y squared plus 53, for 15y plus 17. That's going to tell you the measure of P, Q, and R. To figure out the measure of S, you just take whatever you get for Q and you do 180 minus that to tell you S. So I'm going to move this up here so we have more space to run through this real quick. If we start with the measure of angle P, so P is 5y plus 3. So we're going to do 5 times 8, because that's the value of y, plus 3. So if we do 5 times 8 plus 3, 5 times 8 is 40, plus 3 is going to tell us that angle P is 43 degrees. Next, if we go through and figure out the measure of angle Q, so angle Q is y squared, so 8 squared plus 53. If you do 8 squared, you get 64. So 64 plus 53 is going to tell us that angle Q is 117 degrees. Now, from here, I know 2 angle measures. I can figure out the measure of angle R by plugging 8 in for y. So you do 15 times 8 plus 17. The other way is I know that the measure of angle P is 43 degrees. So to figure out R, all you have to do is 180 minus 43. So if we go for angle R, 180 minus 43, that tells us that angle R is 137 degrees. And then for angle S, we know angle Q to be 117. So if this is 117 degrees, we have to just do 180 minus 117 to tell us the measure of angle S. So angle S is going to be 180 minus 117, and that tells us that angle S is 63 degrees. And that is how you go through and do example 2. So when you are going through and solving problems like example 2, part A, okay, so they're going to give you a diagram with an inscribed quadrilateral, and they tell you the measure of 3 different angles as expressions. Okay, locate the 2 that are opposite of each other. In the case of example 2A, that was angle P and R. Take those expressions, add them together and set equal to 180. Solve for your variable, whether it's x, y, or z. Once you have that, you can plug that back in to your expressions to figure out the measure of the angles. Now, I'm not going to run through the rest of the problems step by step like I did with example 2a, where we went through and took the opposite angles, added them together, and set equal to 180, solved for y, and then we plugged y back into each of these expressions to tell us what angles P, Q, and R were, and then we figured out the measure of angle S by doing 180 minus the angle that's opposite, which was Q. Now, what I will do for parts B and C is just kind of help you set up what you need to do to figure out the value of the variable, and then we will kind of go from there. So if we look at B, so we have our circle with our inscribed quadrilateral JKLM, and they have told us that the measure of angle J is 39 plus 7x. The measure of angle K is 20x over 3, and the measure of angle L is 6x minus 15. So, of those three, which two are opposite of each other? Okay, the two that are opposite of each other are angles J and L. So J and L are opposite of each other. So that means we're going to use the 39 plus 7x and the 6x minus 15. Because those two are opposite of each other, it means they're supplementary and add up to be 180. So we're going to take 6x minus 15 plus 39 plus 7x, and we're going to set that equal to 180. So all you have to do from here is just go through and solve for x, which means you're going to combine like terms. So the 6x and the 7x gives us 13x, negative 15 and 39 is going to give us 24. So we end up with 13x plus 24 equals 180. From here, it's really easy to solve. Subtract the 24, divide by 13, and that tells us that x equals 12. So now that you know x equals 12, that allows you to go through, figure out the measure of angle J, K, and L by just plugging 12 in for x. So it's 39 plus 7 times 12. It's 20 times 12 divided by 3. And then it's 6 times 12 minus 15. That will tell you 3 out of the 4 angles you need to know. And then to figure out the measure of angle M, you just do 180 minus the measure of angle K. So I'm not going to go through and do that for angles J, K, L, and M because I already went through and did it for part A. I don't feel it's really necessary to do the same thing for part B. Alright, so the last one is example 2, part C. They want you to go through and do the same thing as parts A and B. We're going to use the Inscribed Quadrilateral Theorem. They tell us 3 angle measures. They tell us that the measure of angle U is 12z minus 27. Measure of angle T is 125 minus z. And the measure of angle W is 37 plus 5z. So, they tell us 3. First thing to do is locate the two that are opposite of each other. So the two that are opposite of each other are angles U and W. So U and W are opposite of each other. So we're going to use this 12z minus 27 and 37 plus 5z. So because those two are opposite, they're supplementary. So we're going to take 37 plus 5z plus 12z minus 27 and set that equal to 180. We set it equal to 180 because they're supplementary, they're opposite angles, so that means they add up to be 180. So you just go through and solve it like we did for part A and part B. Combine like terms. So the 5z and the 12z gives us 17z. And then 37 minus 27 is going to give us 10. So we have 17z plus 10 equals 180. You would subtract 10, divide by 17, and that tells us that z equals 10. So now that you know what z equals, you can plug z in for the expression on u, for t, and for w, and then you can figure out the measure of angle v by just doing 180 minus the measure of angle t. So the key for this, when you go through and do problems like example 2, find the two angles that are opposite, take both of those expressions, add them together, and set equal to 180. Solve for your variable, whether it's x, y, or z. Once you have that variable, plug it back into the expressions for those three different angles, and then you can find the fourth and final angle by doing 180 minus the angle that's opposite. So with that said, that kind of really wraps up everything for section 15.2 on angles in inscribed quadrilaterals. Just to summarize real quick, I'm going to go back to example 1, and I'm just going to take a look at part C. Okay, so if we take a look at example 1, part C, when you have a quadrilateral that is inscribed in a circle, so a quadrilateral inside a circle, opposite angles are supplementary. So opposite angles in this case would be 112 in x and 81 in y. So 112 and x are opposite of each other, and then 81 and y are also opposite of each other. The inscribed quadrilateral theorem states if a quadrilateral is inscribed in a circle, then the opposite angles are supplementary. That means these two add up to be 180, and these two add up to be 180. So if you know the measure of the angle opposite, to figure out the measure of the angle, all you have to do is just do 180 minus the angle that's opposite. So if I want to know what x equals, all I have to do is look to the angle opposite, which is 112, and we just do 180 minus 112, and that tells us that x equals 68. Same thing for y. I want to figure out the measure of angle y. The angle opposite is 81, so we're just going to take 180 minus 81, and that's going to tell us that y equals 99 degrees. So, inscribed quadrilateral theorem. Opposite angles are supplementary. If you're trying to find the measure of an angle, look to the angle that's opposite. Take that angle measure. For x it was 112. All you have to do is just do 180 minus that measure, and that tells you the measure of the angle you're looking for. So that's what I've shown in example 1, parts A, B, and now C, and what I talked about in example 2 with parts A, B, and C. So with that said, that is it for today's lesson on section 15.2, angles in inscribed quadrilaterals. I hope this video is helpful, and I hope you feel comfortable with the content for today. As always, as you are working on the homework, feel free to reach out to me and just let me know next time you see me, or send me an email, and I'll be more than happy to answer any questions you have over the notes, or any questions that you might have on the homework. So don't hesitate to reach out if you need some guidance or some help. Otherwise, thank you guys for listening. Have a great rest of your day, and I will talk to you guys later. All right, bye.